Let us create automobile engineering drawing exercises. The first exercise is with knuckle joint, and that first part is fork. So let's start creating fork 3D part modeling using CATIA. Okay, and let us give fork here. Okay, let us save it as okay, already existing 402. Okay, now we have to create. In this, you hide this absolute access system and create a point in the 00 coordinate system. And again, you create an access system based on that point as an origin and the start point. Okay, let us create planes in basic geometric set. Two planes. Okay, this 15 mm. Okay, let us see, this is 30 mm, right? So let us create 15 mm, 15 mm, okay, and another plane of 15 mm, that in the reverse direction, okay, okay, and another plane in this at 0 offset distance. Okay. These three planes are required for making this part, okay, and one more plane we may need going forward. Okay, that also will create it. This is at 125 mm, the other way around. Okay, let us see how it goes. Then we have to insert a body. In that body, we have to create a sketch. Okay, using this plane. Okay, in this plane, under the sketch, you, you hide this absolute axis system so that you will create a robust model at a dia of this diameter is, let us see, this diameter is 50 mm and 25 mm. Okay, so 50 mm dia outer circle for the fork, and you make these two coincident and these two coincident. Okay, the under circle of diameter 25. Okay, another diameter, another circle of diameter 25. And in the same way, we make this point and the axis to coincident, and this and z axis to coincident. Now the sketch is good to go, and using the pad and the extrude at a length of 17.5 away from the coordinate axis system. Okay. Similarly, create another body, insert another body. In that body, create a sketch the same way, and you hide all the absolute accesses so that the part moving, translation, and everything will be under control. This dia is 50 mm. Okay, the another dia. Okay, let us constrain this first to this coincident, and these two z axis coincident, and then another circle of dia 25. Okay, another dia 25, and this we can coordinate it coincident with this. Okay, and again we have to make this point simplify to access to coincident. Let's go to go, and using the pad command, the reverse direction 17.5 mm length extrude or pad creation. Okay, now two bodies created, and third body in that plane. Okay, draw a sketch, and this sketch the 16 dia, 16 dia, okay, and this 16 dia again you should make hide that absolute axis systems, otherwise it will align with okay, right. Okay, now this distance, this distance, this distance, sorry, from center point of the circle to the should be 50, okay, and then another draw another circle of diameter 30, okay, diameter 30, and make this center point to this x-axis coincident, and this center point to this y-axis should be 50. Okay, this should be other way around, right? Start with this. Okay. Now draw a rough rectangle somewhere like this. And after drawing this, the default constraints is created by the system should be done so that it's easy to create a fully constrained sketch. To best to this axis, which is 30 mm, right? 60, and this distance should be 60 mm. And let us join this together. Okay, from this to this, from this to okay, from this to this. Okay, is done. And create an offset of 50 mm of this. Okay, 50 mm. And again create an offset of this to 50 mm. Okay, and erase the unwanted things. Erase the unwanted things. Okay, this stuff, everything is constant, and then this stuff is become extra. Okay, now this can be done. Okay, and this can be okay, and what is missing? This entity that distance is missing. This two, this axis is missing. It should be 15 mm. Okay, now everything looks green. Exit the sketch. In this body 4, you make a pad, go to more, and both the directions 15 mm. Okay, now first thing we have to do, we have to assemble the bodies whatever we have created so far to the part body. Okay, second body should be assembled to part body. Okay, okay, and fourth body is assembled to part body. Okay, and the fifth body is assembled, third body is assembled to body. Okay, these bodies now assembled together. And the next thing is we have insert one more body, and under this body we have to create a sketch to revolve around. Okay, for a rectangle. Okay, again as usual you hide the default constraints created in the system. Okay, let us constrain it dimensionally first. This length should be 15 mm. Okay, and from this to that axis should be 125 mm. Okay, okay, and this distance should be 75 mm. Okay, and from here to see again we miss this absolute access system. We should have done it. Otherwise we will refer it by mistake. That will disturb the entire models easily. Okay, and this distance is again we will do. Okay, this is 75 and this is 15. Okay, and the final dimension from this to this it should consider. Okay, now since we are going to revolve it, we have to create an axis. Okay, exit it and revolve it, and then using a shaft revolve it 360. Okay, now you see this body is put to the right, no problem. Then you have to use union trim. Okay, now the body 5 is union trimmed with the body. The face to remove is this one. Okay, now it is assembled together. I think this part is created properly. Okay, let's undo it. The shaft before the shaft, we have to edit this sketch. This distance 125 is right, but this 125 is right, but this is not. This has to be somewhere around 125 plus 50 plus 150. 140. Should be 145. Okay. Okay. Now we can add this body. We can add this body to the body. Okay. There's no issues. Okay, this one, this plane, now it is 145. It should be 145. Okay. In this plane, again insert a body. We have to create a sketch. Okay. Around. And as usual, we will hide these absolute access systems. Okay. And draw a profile, insert a profile of polygon somewhere, and this one so this is not slot. Let us fix this angle to 0, and then this should be editable. Why it's not editable? Okay, let us see. Insert profile, group defined. Okay. Okay. sides we can decrease it. Okay. Okay. And this diameter will 30. And then draw another circle somewhere around the without interacting with any of the surfaces. That's better. Something similar. Again, as usual, the default constants created by this system should be hidden. Otherwise, it will destroy. Okay, draw a circle of 33 so that we can remove this material. This should be coincident, and this should be coincident. In the same way, this center point for this is coincident, and this center point for this axis is coincident. Now everything looks green. Okay. Now create a pan at 37.5 mm length. Okay. Okay. Now you see, okay, this body needs to be removed. Okay, removed from the body. Okay. Okay. This is what we have expected. Again, there is one more body. We have to insert a body. In that, let's start making a sketch. And again, in this sketch, we hide all the default axis systems and draw a circle. Draw a circle of 25 mm. Okay, this is 25 mm. And make the center point in this whole axis coincident, and this center point in this other axis coincident. Now exit the sketch. Now create a fan and reverse the direction, strike for 35. Review it. Okay. Now add this, assemble this body. Assemble this body to the body. Okay. Now this is a complete part modeling of complete part modeling of the fork. Okay, the fork part modeling complete. Okay, this is how we have to create 3D part modeling using CATIA.